Okay, so we have this, we're given 2 points. We have 1, 1 and AB, and we're asked to find the equation of the line through those 2 points and in slope-intercept form. First thing we're going to do is find the slope, and that's just going to be equal to B minus 1 over A minus 1. So when we put it into point-slope form, we're going to get y minus 1, y minus our first y coordinate is equal to our slope, b minus 1 over a minus 1 times x. And I'm sorry, this should be an x minus 1. So we have x minus 1. So this is minus our x value from the same point. Okay, so now we're going to make this y is equal to b minus 1 over a minus 1, our slope, times x, minus b minus 1 over a minus 1 plus 1. The plus 1 coming because we added 1 to both sides to make it just y is equal to. Okay, so now we're going to rewrite this as y is equal to b minus 1 over a minus 1, and that times x, and we're going to change this to a plus. So that's going to have to change this to a negative b and this to a positive 1 over a minus 1 plus a minus 1 over a minus 1. And what we did is we just replaced this 1 right here with a minus 1 over a minus 1 to give it the same denominator as this other fraction here. So now we're going to simplify. We're going to get y is equal to b minus 1 over a minus 1 times x. So again, our slope times x. And then when we combine here, we know we're going to end up with a minus 1, and we're going to end up with a positive a minus b, and then our positive 1 and our negative 1 cancel out, so we just end up with a minus b over a minus 1. So there we have it. We have our slope, b minus 1 over a minus 1 times x, plus a minus b over a minus 1 as our y-intercepts. Okay, line A has intercepts of 10, 0, and 0, 6. Find the equation of the line that is perpendicular to line A and has an x-intercept of 6, 0. Okay, so line A, first of all, has a slope equal to 6 minus 0 over 0 minus 10 is equal to 6 over negative 10 is equal to negative 3 over 5. So if we want a line that's perpendicular to line A, it has to have a slope. It has to have a slope of positive 5 over 3, the negative reciprocal. So we also know that one of the points of this is 6, 0. So using our point slope form, we get y minus our y coordinate is equal to our slope times x minus our x coordinate from the point. So we now will replace this with y is equal to 5/3 x minus 5/3 times 6 is going to give us minus 10. And we want this in standard form, so we're going to multiply everything through by 3 to give us 3y is equal to 5x minus 30. Or, because we want to keep this positive, we're going to add 30 to both sides to get 30 is equal to, and we'll subtract 3y from both sides, 5x minus 3y. Okay, so we want to find where these two lines intersect. So that means we have to now completely find our line A equation. And so we already know its slope is negative 3/5. So we'll plug in this point here into point slope form. Y minus 0 equals negative 3/5 times x minus 10. And that's going to give us y is equal to negative 3/5 x plus, because negative by negative, 30 over 5, so that's going to give us 6. Now I'm going to make this into standard form to get 5y is equal to negative 3x plus 30, or 3x plus 5y is equal to 30. Okay, now we want to find where these two lines intersect. we have 30 is equal to 5x minus 3y. 3x plus 5y is equal to 30. So we're going to use elimination. So that means we're going to multiply one or the other equation, or both, so that we can, in this case, let's get our y values, our y coefficients to be opposites. So we're going to multiply this equation up here by 5, and we're going to get 150 is equal to 25x minus 15y. Okay, so that was again multiplying this equation up here by 5. Now we're going to multiply this equation by 3 to get, and we'll rearrange this, 90 is equal to 9x plus 15y. When we add these together, we get 240 is equal to 34x, and x is equal to 240 over 34, which is equal to 120 over 17. Okay, so we know that we can now replace, we'll replace x in one of our equations. So let's say that 3 times 120 over 17 plus 5y is equal to, I know I'm going to have a fraction of with a denominator of 17, so I'll make this 510 over 17. That's going to give us 360 over 17 plus 5y is equal to 510 over 17. And we're going to end up with 5y is equal to 150 over 17. So y is equal to 30 over 17. Okay, so our x is 120 over 17. Our y is 30 over 17. Okie dokie. Okay, so now let's take a look at our temperature problem. And we're going to create 2 points here. We're going to create the point, we'll say the point 100. Let's see which way we want to do this. Convert Celsius to Fahrenheit. All right, so say 100, 212, and 0, 32. So we want to find the equation of the line that passes through those 2 points. So we got our slope is going to be 212 minus 32 over 100 minus 0. It's going to be equal to 180 over 100 is equal to 18 over 10 is equal to 9 over 5. We already know that, well, we can plug in now one of these points and say that y minus 212 is equal to 9/5 times x minus 100. So that gives us y minus 212 is equal to 9/5 x minus 9/5 times 100 is 180. And we're going to add 212 to both sides to get y is equal to 9/5 x plus 32. So x is our Celsius, so we plug it in, we get x, 9/5 times our Celsius plus 32 will give us our Fahrenheit. Okay, now to find where the two temperatures are equal, we said x was our Celsius, so we're going to set our Celsius equal to our Fahrenheit, which we can express as 9/5 x plus 32. Okay, so we're going to subtract 9/5 x from both sides to get negative 4/5 x is equal to 32. And then we'll multiply both sides by negative 5 over 4 to get x is equal to 32 times negative 5 over 4, or x is equal to negative 40. And that means when the Celsius temperature is negative 40, the Fahrenheit temperature will also be negative 40. And how can we confirm that? Well, let's plug negative 40 into our equation. 9/5 times negative 40 plus 32 is going to give us negative 32 plus 32 is going to give us 0. Okay, now we're saying where the temperature in Fahrenheit is exactly 10 times the temperature in Celsius. Well, we say now 10x is equal to 9/5 x plus 32. Subtract 9/5 x from both sides, and that's actually going to give us 8.2x because 9/5 is equal to 1.8 is equal to 32. And we're going to say x therefore is equal to 32 divided by 8.2. And that's going to give us a value a little bit under 4, but you can calculate that. Okay, for our next problem here, when you are pricked with a pin, there's a short time delay before you say ouch. The reaction time varies linearly with the distance between your brain and the place you picked. Okay, so we have here that we have our distance, which we'll say is the independent variable, and the time is the dependent. Okay, so now in this problem, we have that a relationship between how long it takes for you to say ouch and the distance of the injury from your brain. And so we're saying that the distance, 100 and 170, those are the independent or x coordinates, and the reaction time, 15.2 and 22.9, are the y variables. So first we'll figure out our slope. We're going to get 22.9 minus 15.2 over 170 minus 100. It's going to give us 7.7 over 70, which is going to give us 0.11. So now we can plug into the point slope form to get y minus 15.2 is equal to 0.11 times x minus 100. And that's going to give us y minus 15.2 is equal to 0.11x minus 11. And we're going to add 15.2 to both sides to get y is equal to 0.11x plus 4.2. Okay, so now how long would it take the subject to say ouch if pricked in the neck 10 centimeters from the brain? Well, now we can just plug into our equation 10, so 0.11 times 10 plus 4.2. That's going to give us y is equal to 0.11 times 10 is 1.1 plus 4.2 is going to give us 5.3 milliseconds is the length of time required for this to for you to say ouch. Okay, so what does the time intercept equal, and what does it represent? So the time intercept in this problem is equal to 4.2 seconds, and what that represents probably is the time needed for brain, so time needed for brain to register the pain. Okay, since the slope is in milliseconds per centimeter, its reciprocal is the speed which nerve impulses travel in centimeters per millisecond. So how fast do they travel in centimeters per second? We'll do 1 over the slope. That's going to give us 9.09, or about 9.1 centimeters per second. Okay, so next one here, we're told that the distance between a line and a point is the shortest distance from the point to the line. Find the distance from the origin to the line 2x plus 5y equals 20. Okay, so whenever we find the distance between a line and a point, we're always going to find the perpendicular distance. So in this case, we have the line 2x plus 5y is equal to 20. And if we were to graph that, it would look sort of like this. So when y is 0, x would be equal to 10. So this would be 10, 0. And when x is 0, y is equal to around 4, or equal to exactly 4. So we have 0, 4. And so this is what our line looks like, more or less. So we want to figure out the distance to the origin, and so that distance would lie along this line right here that is perpendicular to our original line. So we're going to find the slope of our original line first, and so to do that, we're going to put it in point slope form, or rather in slope intercept form. We're going to say 5y is equal to negative 2x plus 20. Y is equal to negative 2 over 5x plus 4. So that means that we need to find the slope of our perpendicular line has to be 5 over 2. We know that since that line is going through the origin, its y-intercept is equal to 0. So that means in slope-intercept form, we have y is equal to 5 halves x plus 0, or just y is equal to 5 halves x. Okay, so then we need to find what is that point right there? What are its coordinates? So we have to find where these two lines intersect. Okay, so let's go back to this line here, and we know that the other line, we want to set that, we can now replace y with 5 halves x. And so that will help us figure out what value of x makes, and what combination of x, y makes both of these equations true. In other words, what would be the coordinate of this point of intersection. So we're going to replace y, so we're going to end up with 2x plus 5 times 5 over 2x is equal to 20. And that's going to give us that 2x is equal to 2x, well, let me back up a little bit here. Let me do this where there's a little more space. So we're going to say that 2x plus 5 times 5 halves, or 25 over 2x is equal to 20. And that's going to give us that 2x plus 12 plus 25 over 2, or 12.5. So 14.5x is equal to 20. X is equal to 20 over 14.5, which is equal to 40 over 29. And we said y is equal to 5 halves x, so y is equal to 5 halves times 40, or 100 over 29. So the coordinate of this point here is going to be 40 over 29, comma, 100 over 29. So again, what we needed to do was, once we had our line, and we wanted to find the distance from the origin, this point right here, to our line, we had to find the line that is perpendicular to our line that goes through the origin. Okay, so now we're going to do another one of these. All right, the distance from the point 27 to the line y is equal to negative x minus 5. So since this line has a slope of negative 1, the negative reciprocal of that is just positive 1, so our new line is going to be y is equal to x plus b. We don't know what the y-intercept is, but we can now plug in into the point slope form. Y minus 7 is equal to our slope, which we said was 1 times x minus 2. And that's going to give us y is equal to x. We have x minus 2, but then we're going to add 7 to both sides, so y is equal to x plus 5. So I have to figure out where y is equal to x plus 5 and y is equal to negative x minus 5, where they intersect. So we're going to set these two lines equal to each other. So we're going to get x plus 5 is equal to negative x minus 5. We're going to add x to both sides to get 2x is equal to, and we'll subtract 5 from both sides, negative 10. So x is equal to negative 5, which means that y would be equal to, since we said y is just equal to x plus 5, y is just going to be equal to 0. Okay, so now we are going to figure out the distance from the point 27 to the point negative 5, 0. So this is what we do. We use basically the Pythagorean formula. And basically we're saying if on this, well, let's draw it down here. Let's say we have coordinate plane here, and we have the point, say 1, 2, and then 7, say that's up here, 2, 7, and we want to find the distance to the point where x is negative 5 and y is 0, so let's say that's around here. We want to find that length, so basically we're going to make this into a right triangle, and we're going to figure out that this distance from y is 0 to y is 7 is going to be 7, and this distance from x is equal to negative 5 to y is equal to x is equal to 2 is also a distance of 7. So basically our distance is just going to be the square root of 7 squared plus 7 squared, which is just going to be equal to the square root of 98, which is just equal to 7 times the square root of 2. Okay, so that's our distance there. All right, so now we have y equals x squared intersecting y is equal to 5x. We have to find the distance between those 2 points. So first we have to find where they intersect. So when we intersect, we're going to set the right side of each equation equal, and that'll give us x squared minus 5x is equal to 0. So x times x minus 5 is equal to 0. So we get x is equal to 0 or 5. And that's going to give us y value for this of 0. And the y value of our other, when x is equal to 5, that's going to be equal to 25. So we want to find the distance from this point 0, 0 to the point 25, 5, and that's just going to be the square root of 25 minus 0 squared plus 5 minus 0 squared is equal to the square root of, this is going to give us 625 plus another 25 gives us 650, which is also equal to 5 times the square root of 26. Okay. All right. Grid above, we have to quickly sketch the graphs of the following equations. Okay. 3x minus 8 equals 24. Quickly, we can say that when x is 0, y is going to be negative 3. So we're going to have this point right here. When y is 0, x is going to be 8. So that's our other intercept right here. And now we have one of our lines. It's going to go right through this, more or less. Okay, x over 5 plus y over 6 is 1. This immediately gives us our x-intercept of 5 and our y-intercept of 6. And so now we can draw a line that goes through those 2 points. Terrible line, but you get the idea. And then finally, y minus 12 equals negative 1.2 times x plus 5. Okay, from our slope-intercept form, we know that negative 5 comma 12, so with an x value of negative 5 and a y value of 12, well, we can't fit that on here. All right, so let's see, when x is equal to 0, y is going to be, well, when we work this out, we'll get y is minus 12 is equal to negative 1.2x minus 6, or y is equal to negative 1.2x plus 6, added 12 to both sides. So that means that we're going to have the intercept be 0, 6 from that. And when y is equal to 0, we'll find the other intercept equals negative 1.2x plus 6, or negative 6 is equal to negative 1.2x, or x is equal to 5. So our other intercept is right here. Turns out that these two lines have the exact same equation. Voila.